How primitive and reference data types are managed and accessed in the memory. So first of all, we take a look at what data types are. Data types define the type and size of a data within a programming language or within a computer. So this simply means that data types are able to store any kind of value you input into your program or into your computer, as well as accept or define which type that particular variable or that particular input contains. So over here, when we look at the definition, it says data type define the type and size of a data a variable can hold. Java categorizes data types in two main groups, which are the primitive data types and the reference data types. So the primitive data types are the built-in types that stores actual value, and then the reference type stores memory addresses, which are also called references. They store them into objects. So what are primitive data types? Like we said, they are the data type that stores the value straightforward. They store the actual values. And also here we have types of primitive data types, their sizes, their ranges, and the examples. When we take a look at byte, byte has 8 bits and can store values within negative 128 to positive 127. And this is the examples of declaring a byte data type. You declare it by stating the data type, and then you state your variable name, then you assign it to the value you want to assign that data type to. And you need to make sure that the value you are assigning to falls within the range. For example, you can't type 1000 and store it into bytes. It's not going to be possible. So these are the types of primitive data types and their sizes. Primitive data types to also somehow categorize. We have the numeric types as well as the non-numeric types. So the numeric types are the bytes, the short, the int, the long, the float, the double. And the non-numeric type are the character and then the boolean. Like the name says, numeric data type stores only numbers. You can't store strings or characters or alphabetical characters or non-numerical characters in any of the numeric data types. It's not going to work. So we move on to how primitive data types are managed in the memory. Like we said, they have fixed size. They are stored straightforward. If you declare a variable of integer 42, it stores integer 42 straightforward. It stores it directly. When you store a double value of, let's say, 3.1419 or 14 anything, it stores it straightforward. The same way goes to the character data type as well as the Boolean data type. So when we take a look at the memory management, it stores fixed size. It stores fixed size. Example, integer always uses 4 bytes. When you take a look at this, it stores in stack memory for efficiency. So this is what the primitive types does. It stores the values in a stack, and it does that for memory efficiency. And over here it says that cannot be null, which means that it must have default value or it should be 0. For instance, 0 for numbers and false for boolean, or this particular encoding for character. So when you are declaring a data type, even though you don't want to store anything, it's advisable to initialize it with 0. Else, if you leave it that way, one thing I've learned is that if you leave it that way, it stores some range of numbers within it, and then yeah, so it cannot be null. Now we take a look at the reference data types. So reference Reference data type stores the values or your data using their memories. So it stores the memory addresses of that particular data type or that particular value you've assigned it to. So it stores the address pointing to the object in the heap memories. In other words, it stores the addresses or the memories of whatever value you have inside the heap memory, and then it points it to the objects. So we have examples of reference data type. You have the class, the arrays, as well as interfaces, enumerations, and the whole lot. So these are just a few. Now, talking about memory management for reference data type, variables store a reference, which is the memory address, in the stack. Actual object data is stored in heap. So let's say you remember we spoke about the primitive data type storing the variables in the stack. Because you have values, the values will be stored in the stack, which is what this is saying. So the values will be stored in the stack, and then after the values are stored in the stack, then our memory of that particular value will be accessed in the heap, or will be pointed in the heap, or will be stored in the heap. That is what this is saying. So, and over here you could see, so a primitive direct stores in the stack. For example, we have the integer equals 5 and then holds 5 directly. This is just differences between primitive and reference data type. So over here, you will see that we have we have the integer storing integer 5 directly. It holds this in the stack directly. But over here, you could see that we have a string data type, and a string is a reference data type. So string or variable s is storing or is assigned to high. So over here, this high will be kept in the stack. Fine. After it's kept in the stack, the memory of this high will be stored in the heap. You will see it here, reference. Stack holds the address, heap holds the object. So the address of this particular value will be stored in the stack. And then the memory that points to this particular value of of the reference data type is stored in the heap. You could see the considerations here. We took a look at aspects, the primitive types and reference types. So another aspect, when it comes to speed, primitive data types, because they store in the stack, they are very fast. Yes. When it comes to speed, as for speed, stack in data structures and algorithms, stacks are much faster. So over here, primitive types, when it stores in the stack, it's very faster. Now, when it comes to reference, it's very slower in the heap. Now, coming here, memory. Primitive uses less memory usage. Yes, of course, because we are storing it straightforward. We want to store the value straightforward, like integer x is equal to 5. It's just straightforward. So it uses less memory. But for reference, it uses more memory because at least it must contain the value, it must have the address stored in the stack, and then hold the memory in the heap. These are all the things that constitute to the memory management or constitute to memory overusage or overhead. When you talk about garbage collection, it's not applicable to primitive types, but it is applicable and managed by reference data type. So reference data types manages garbage collections. Null values. No, it's not possible under primitive types. And reference types can be null. For reference types, they can be null. Now, over here, this is the most important one. Now, we have the pass by value or pass by value and pass by reference. Now, let's take a look at how primitive are done. So, when you pass a primitive to a method, Java creates a complete copy of the value. When we say method here, we are talking about functions. Any function under a class is called a method. So when I declare a data type, when I declare a value of type integer, let's say of type integer 22, and then I create a method which could maybe manipulate or change any value that is passed to it. The moment I call that method and input any value within inside, because I already declared under the method that when the method is called, this and that should happen, or a number should be assigned to this, it replaces or it overrides the value. Just a copy of the value is changed, but the original is maintained. When you take a look at this snippet, this code over here, you could see that this code here, you could see that we have our main method, and then we want to store a value. We've declared an integer value of 42. Now we display the value of 30 or 42, which would display 42 for us, of course. Then let's say we declared a method somewhere, and then the method is supposed to change. So let's say this is the method we declared on top. Let's say this is the method. So this method here, this is how this method is supposed to work. So the method takes in a parameter of integer number. Then any number that is passed in the parameter as an argument must change into 99. Must change into 99. This does not affect the originality of our original number. This only creates a copy. When we undo this method, our 42 remains the same. But in this case, when we call the method and then we pass in our number or our original number into it, it replaces it with 999. It replaces just a copy of it. It doesn't affect the original number that we have on top there. It does not affect it. So this is why we have the pass by value and pass by reference. So this is the pass by value. Pass by value. So our original number will not be touched. Just that a copy of a new number would replace it temporarily. After it replaces temporarily, we can use that temporary number for anything. But after the program is done and we are finished, our value that we stored in the stack as 42 remains 42. It remains the same. That means the copy or the temporary copy will be wasted or will be taken away, and then our original value will remain the same. Now let's take a look at what happens. Like I explained, one says original variable stays in the calling method's memory. 2. A copy is created and passed to the method. 3. Changes to the copy don't affect the original. Just like the way I explained it, the original value remains the same, just that a copy of what the function says we should do is just going to happen, because this method that we declared down here says that any argument that is passed inside when this function is called, if we call this function and the argument is passed through it, this is what is supposed to happen. And remember, we have 42 here. So if we pass our original number, our original variable, you know this original variable already contains 42. It contains 42 here. So when we call it or when we system out it, we're going to get 42 as our output, because that is what we assigned it to. But in this case, when we pass it to the function or to the method, the original number will stay. It will not get wiped out. It will stay, just that a copy would replace it. And it's not going to replace it in the stack or in the memory. No. It's just going to be like a mask. It's going to be in place of our original number in terms of displaying, not in terms of storing. In terms of storing it in the stack, the 42 remains 42. But in terms of displaying, because the method was called and according to the behavior of the method says the number should have 999, it's going to display 999 instead of 42. That is what we mean by pass by value. Now, when we have pass by value for primitive, definitely we are not going to leave reference, right? Before I go, the key point. So the key point says that the original variable is completely unaffected because only a copy was passed. So that is what it's about. That was all the explanations I spoke about. So because we have pass by value for primitives, definitely we must have pass by value for references. Now, pass by value for references. If primitive only replaces a copy of it, what does pass by value for reference does? Over here, Java passes a copy of the reference memory address. So that's the only difference. Instead of passing a copy of the value for primitive, reference passes a copy of a reference or memory address. What happens? The reference memory address is copied. Both reference points to the same object in memory. Changes to the object affect the original because it's the same object. Now, when you take a look at this code snippet, we have our function, our class here as pass by reference. We've already declared our class and we have done what we're supposed to do. So you can see we have declared an integer array which stores 3 elements and the values are 1, 2, 3. This is already declared, so these values 1, 2, 3, 1, 2, 3 are stored in the stack and the memory is pointed in the heap. Now, definitely when we print it out, we are going to get 1, 2, 3, which is over here. When we print it out, we are going to get 1, 2, 3. Now, this is what happens when we call a function. Let's assume this is our function. I'm still saying function. Let's assume this is our method. And this is the behavior of the method. Okay, this is the behavior of the method. The method is supposed to take in a parameter, and the parameter is supposed to be passed by an array as an argument. So when we pass the array as an argument, we are supposed to get this. This is what is supposed to happen. No matter whatever value we have, this is what is supposed to happen. Now, over here, we call the method. Let's assume we declare this method somewhere. So we call this method. Then we pass in our original array, which is this. Even though we've already declared this as 1, 2, 3, but we still want to pass it. When we pass it, check it out here. After we pass the original array, we are going to get this. This is what we're going to get. So our output is going to be 999.2.3. Why? Because we are passing it only in the first index. The first index 0. So the object has been replaced. The object has been replaced, but over here, check here. It says changes to the object affect the original because it's the same object. So we pointed to index array 0. And over here, our index array 0 is 1. So the object will change. Okay. Now, both references point to the same object in memory. Array, 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 they are pointing to the same object in the memory. So key point, the object itself is modified because both variables point to the same memory location. Both variables point to the same memory location. So our variable original array is pointing to, we assume we have our memory location. Let's assume this is our memory location for our array. So we declare it here and it has been stored here. Now we create our function. So we create the function, then we pass in the value. We pass in the value, the argument of our original array. It changes because this is also pointing over here. So let's say new. Let me use n as new. Let me use O as old or original. My original array is pointing here. So the new one that I declared will also point at the same place. It also points here. Why is it pointing there? This original array contains 1, 2, 3. So when we point this new one at the same memory location, when we point to the same memory location, then we can be able to modify any of the values contained in that array. If it doesn't point to the same memory location and it points somewhere else, which is not possible, we cannot access this. We can't change this one. We can't change any of the values here because this is going to be a null memory. This is going to be an empty memory. There's nothing here. So we cannot modify this. But because arrays, they point to the same memory location, so we are able to change. Just like what it says here, the reference memory data address is copied. Both reference point to the same object in memory. Changes to the objects affect the original because it's the same object. Okay, so the object here is talking about the values of the array. That is what the objects are. When you change the object in the original, it affects, sorry, when we change the object from our new method, it affects the original. Why? Because, where is it? Because it's the same object. They point to the same memory. It's here. Both reference points to the same memory. That is why we are able to change it. Like the examples I gave here. If our new method is not pointing over here, we will not be able to access and change any of these arrays. It's not going to be possible because that is how Java has structured it. Now, this is just a pictorial example of how it's done. So over here, we could see that inside our main method, we have the value as this. That is inside our main method. And then the method, our user defined method or a method we created is supposed to change the value from this to this, from 42 to 999. So we pass it there, it just changes it to 999. It just changes the 42 to 999. It doesn't affect anything in the memory or doesn't affect the object in the memory. It only affects the value and changes the value to 999. Now, when we come to pass by reference, now this is how it is done. We define or we declare our array. Okay, our array is stored in address 1. This is the address. This is the address we have over here. Now, we've already declared some values inside as 1, 2, 3. Now over here, changes are made in our method, and this original array has been passed. This original array has been passed. This one right here. It has been passed in this method, this change array method. Because they are both pointing, you see, this is the whole address 1. Let's say this is the portion of address 1 in our heap. Remember I spoke about them in the stack, right? So this is the stack. Our arrays are stored in the stack, but their memories are contained in the heap. So over here, we are able to reference 1, 2, 3 in the heap. When we reference it, we can get the values when you want to print. So when we pass this original array in the change array method, it points to the address, it points to the reference. So it points there and then it locates, okay, you want to change 1, 2, 3 to what? Index 0. We want to change it from we want to change it at index 0. When we change at index 0, it looks, where can we find index 0? Where is it pointing at? Okay, index 0 is here. So it picks it from here and then it changes it to whatever value the method is saying. After that, it allows you to print it out, or it prints it out for you. You could see here copy of reference. So it points to the reference and then changes it into the behavior of that method. So that is it for primitive and and reference data type and how they are managed in the memory.